together with the binary operation. Together with the binary operation. That satisfies the following properties. That satisfies the following properties. So one, anytime we say a particular an empty set together with any given binary operation is a group, then it must first be closed. What do you mean by closed? So you must satisfy the closure property. That shows it is closed. Now, when you pick any two given elements from any group, same thing, and then you perform a binary operation, let's say A, operation B, and the answer is also a what? Chain. Then we say chain is what? Now, for any given an empty set, a group, the binary operation to be a group, it must also satisfy associativity property. Associativity property. That says that if A, B, C are in a group game, then A, operation B, operation C equals A, operation B, operation C. So it means it must satisfy the associativity properties. So when you move the parentheses above, you see the parentheses was in front. The first two lines, the last two. When you move it above, and then you get the same result. It means this one, associativity. So the third property, identity element. So there must exist. There must exist an identity element. There must exist an identity element. Say E. So there must exist an identity element. Say E in the given group. So we all know that the next element for addition is what? The next element for addition is what? Right. So you should know that. Now the fourth property says that every element of the given and empty set, must have an inverse. Must have an inverse. Every element of the given and empty set, so given by that operation, must have what? An inverse. How do you write the inverse of the binary operation for addition? Is it not negative? Yes. So if you add, we are saying that so from here the identity element, A operation identity element, give us identity element operation A equal to what? B. That's why the identity element value is 0. The add 0 to anything, you get the same thing. The identity element for multiplication is 1. If you multiply 1 by any this thing, you get what? The same element. Likewise, if A is in the given an empty set, and then A inverse is also in the given an empty set, then A operation A inverse is the same as A inverse operation A inverse the identity element. So when this is satisfied, and then every element has one is equal inverse means it is part satisfied. So if any an empty set, a group with a binary operation satisfies all these four properties, then we say such an empty set is what? A group. So give us a few, let's stop.
comma R, plus.
No, like this.
Yes.
Comma, the set of real numbers and addition a group
A set
of real numbers
of real numbers
and addition
and
Addition.
addition
A group.
a group.
Question mark.
Okay, so example 1. It is actually a group or not. The first one says closure. So let's see whether real numbers are closed under addition. Are they closed? Real
Yes.
numbers are closed, right?
Yes, very.
And addition, yes. Because if you take A, B, in R, and you add there, the answer will also be in what? R. Is it not true?
Nice.
Yes. So it's closed. Is it associative? Yes. It's associative. So if you move the parentheses about, you will get the same result. Move the parentheses about and add, you will still get the same answer. So it's closed, associative. The final operation does not have an next element. Yes, the final operation is addition. So identity. So the final operation has an identity and that is what? Each called what? It's zero. It's addition. The next element for addition is what? Zero. So does every element have an inverse? Huh?
Yes.
Does every element have an inverse?
Yes.
Yeah. So if you take A and add to like A, you get what?
Zero.
You get an element. Is that what? You get an element. And then zero. So you might get what? Zero. So add the negative of it to it, so you don't get zero. Is there any number like that? Eh?
No, sir.
There's no number. Final operation is a. Give us example 2. Like this.
and an multiplication.
And then multiplication.
Equals to sets.
Nothing can.
Brackets.
Like this.
Yes. X, a member of real number.
X is a member of the number.
X greater than 0.
X greater than 0. And
A
your
set of positive real numbers
okay.
and an multiplication table.
A set
Positive real numbers
of 2 real numbers
and an multiplication.
and
Multiplication is a group.
of 2. That means it must be a group. Can you see the question? They say shoe. It means it must be a group. Is that not the meaning? That's the meaning. Right there, it says shoe whether or not. It can be or it cannot be. The man who was here, what did he say? The lecturer was here, what did he say? Equal to this. It says the positive real numbers and our equation is the same. So let's see the first one. Blue. Is it close? Yes, it's close, right? Yes. Multiplication. You multiply any 2 real numbers, 2 positive real numbers, except zero. That's not what I said. The 2 positive real numbers, you get a real number, right? That's it. So pick any AB in R positive. And you multiply that, you should get what? R positive. Yes or no? Yes. So it's close. 2 associativity. If you move the parentheses about, what will be associative? It will be, right? Yes, it will be. Multiplication is what? Associative. 3. Does that have an next element? What is the next element? The next element is what? Is 1. Are you also? Yes. So we have an element. Does every element have an inverse? a group. So, our positive value operation is a group. Is a group.
Q and addition. The set of rational numbers and addition a group of rational numbers and addition a group.
Addition
A group.
a group. So let's see whether it is indeed a group or not. One. Should we close and addition? Yes. What was it? Pick any two rational numbers and add them. The result was being what? Is it true? Yes. Associativity. Associativity. Yes. Associativity. Move the parentheses with addition. You get the same thing. So the third one says identity. What are the elements here? The next element was it must have identity element. What will the element? Zero. Our final operation is addition. So it's zero. You have to pick. If you pick any rational number, you will break it. Within 1 get to receive an element. So we have element as well. That's every element has an index. Every element has an index, right? Or has an index. Every element has an index or have an index. Every element has an index. Okay. So it has. So every element has an index. Okay. This addition is A. We add A. Negative A. We get what? The element has an inverse. So is this a group? So, set the rational number and this is a group. Maybe close that way. So what is the inverse of this element in this collection? Is this? Is this still in this collection? Yes or no? This is where you tell it. Are you on here? So the inverse of an integer and a multiplication is 1 to 1. That's the number. Which doesn't fall in the collection of what? Easy. So we cannot fall our collection 1. Because already the inverse has an inverse already. But are those inverses part of the original collection? You know you are proving anything that matters. You can't find my pen, where I wrote pen, right? Look for it. Everything.
Get up.
Where is the file? You know this one you gave us 4. What? 5. What is 5? See this one. What? Look for the 5.
That's the 5. That's 44. So make another 4.5.
You just say 5. Show whether
Or not.
show whether or not.
Rational number.
Eh?
Open bracket. That's Q. Rational.
Right now the best.
Yes.
And the what?
Comma. Dot.
Dot.
Close on. Yeah. Dot. Comma. The set of rational numbers and the multiplication is a group.
The set. About with this one. Oh, they need. Doing this, check your books. Which of the exam? Now we did something like that. We did addition. Right?
Yes, this is multiplication.
Okay. So show whether or not. So let's see. Are you okay? So the first one is closure. So let's see if you pick any two rational numbers and you multiply them, whether you get a rational number. Is it closed? Is it closed? It's closed under multiplication, right?
Yes.
Associativity. Associativity, eh? Is it associative? Okay. So it's associative. You pick any three, and then you alter in the parentheses, the bracket. You'll get. So what's the identity element for? You see, so identity element talks about the operation. Are you there? Not the collection. See? It talks about the operation, not the collection. The operation under the collection. So it talks about the operation. The operation, what is the identity element for that operation? Is what? Is 1. So E is 1. Can you all see? So rational numbers has what? The operation dot has identity element E 1. If you pick any rational number and you multiply by the identity element, you get back what? The rational number. Now let's go. Let's pick the inverse of A, and the multiplication is what? 1 over what? A. So let's see whether rational numbers, whether there's any rational number that doesn't have an inverse. Joshua. So if we pick, I want you to do the inverse of
All of them have
the inverse of the rational
all of them
number.
have except 0. All the rational numbers, they all have except 0.
Except
They all
Except
have 0. They all have the inverse except 0, which is 100.
they all have inverse.
Yes.
Can you see where we are proving? Can you see where we are proving it? Can you see how we are proving it? We are proving with the inverse. All of them we are proving with the inverse. So the A inverse must be 1 over A. So if you pick every rational number, you can find 1 over that number. Can you all see? Then it will fall in the collection. But when you pick 1 over 0, what will you get? We'll get undefined, right?
Yes.
Undefined. You get undefined. So because of here, something under the collection has no inverse. See that we don't need to go and say A operation A versus E. Do you see? Right there.
It's not the provide.
It's the inverse of the individual elements of the collection. That is where we are proving and showing whether every element will have one and inverse. So we can conclude here that and that this it's not a group, eh?
Yes.
It's not a group. It's not a group. It's not a group.
Okay, now go to now go to 6.
Numbers pi and then E. That's what I remember in the
Verify that. Verify that. Correctly here. Copy first. Copy. Copy. No problem.
Now it's people
So you see that when you are identifying the identity element, you are identifying the identity element for the operation. So you ask yourself, does that operation in the collection, does it have an identity element? Yes. Multiplication has an identity element. You see, it doesn't mean that the identity element must be inside the collection. No, that's not what we're talking about. It must have an identity element.
To R.
Equal to
R.
R
Minus.
minus
Curly bracket open. Minus 1. Closed. Dot. That's full stop. Define
define
operation. Start. That's
Define.
start.
operation start
On S.
on what?
S. Set that.
All right, and what?
Set that.
Define this on this and
Set that.
say that.
A star B.
Say that A
Star B.
star B
Equal to A plus B.
equal to
You
A
don't want to be taking the mass
plus B
Plus
plus
AB.
AB.
So
Show
yes.
show
Whether
whether
or not.
or not.
Bracket open.
Bracket open.
S comma.
S.
Yes comma.
This one.
Yes comma. Star. That's the line.
That's that.
And close. It's a loop.
Is a group. Stop. Fence down, everybody. Fence down. Fence down. Fence down. Okay. So let's work it together. The first one, closure. Are you all watching? The first one talks about what? Closure. So if you pick any two pair of elements in the collection, the result you get must also be where? Inside. You see what we are talking about? Must be inside. Now the meaning of closure. Yes. What is our binary operation? Now who can tell us the meaning of this? A set of real numbers excluding negative one. Can you see? You see the meaning of the set? What does I say? The set of real numbers minus this, excluding this one, this collection. That's the meaning. Excluding it. Do you see? So these are real numbers. And you know negative one is also a real number. But they say don't include it.
So that's
All other numbers except negative one. That's all.
So, writing this way is this algebra language.
It's mathematics.
Wouldn't you have just done it as a set of real numbers except minus 1?
And if you want to write it in West, that's the West. That's how you write it in West. But this is the representation. So we are picking any. Are you watching? So look, if you pick any two real numbers, right? In which none of them is negative one. So they say add the two real numbers, right? Add them, multiply them, and then add the result of the addition. Can you see? Is there any two real numbers? Say that when you add them and you multiply them and you add all, you will not get the collection. You will not get the answer in the collection. Yes. Is there any number? Give me the number that does not satisfy this. Is there any number? No. Can you all see? So whatever you do, A plus. So if AB is in F, A plus B plus AB is also in what? In F. It's also in S. That's the collection. I straighten it. Let's see whether you pick any three. If you pick any three, A operation B. Are you watching? A operation B, operation C. A operation B, B operation C this way. It will give us A, operation B, operation C. Is this going to be satisfied in all cases? Are you watching? If you move the parentheses about, it was this way on the right, now it's on the left. Is there any way you do that you don't get them to be equal? Is it possible? No. Any three real numbers in which none of them is negative 1. If you do the first two, add, multiply, find the sum. After do the same to this with the result, then see and do it this way and see whether you not get. So here is what closed, right? It's closed. Here is what associated. So let's go to 3. Identity. And we said what? Identity talks about what? Identity talks about what? Binary operation, right? So all along we have one plus, multiply, is that not it? Multiplication, addition, that was they would also our binary operation. And we also said under binary operation that we can describe the symbol. So here they have described it with a symbol for us. What the definition? Yes. Are you watching? So you are going to use this to find what? Your identity element. Are you also? So A, operation E, what they call the what? A. So let's define this. A operation E. The definition is what? A plus what? Plus what? AB, right? AE, sorry. It's not AE. AE. Thank you. It's equal to what? A. We did this under binary operations already. So we can send this across, right? The level is E plus AB becomes A minus A. Yes, what? 0. So we factorize here. E to bracket what? 1 plus A. We divide through by what? 1 plus A. Divide here by 1 plus A. E is equal to what? 0. Are you seeing? So this binary operation has what? An identity element. Do you see? So if you work and it doesn't have, then you are getting 1 over 0. It will not have an identity element. Do you see? And here it has an identity element. 0 is the number, right? Yes. Binary operation has an identity element. Once it has, they say the binary operation must have an identity element. That's the property. So in this case, it has an identity element. So it is satisfied. So let's go to the fourth one. The fourth one is what? Every element must have what? Yes. Anti-inverse. Every element must have anti-inverse. Are you watching? So let's see. Every element must have anti-inverse. A operation B is equal to what? A plus B plus AB. A operation what? B is equal to A plus B plus AB. And then we know that A operation A inverse. So A operation A inverse will be equal to what? A plus what? A inverse. Is that it? Plus what? A plus A inverse plus A inverse is equal to what? E. Is that not the rule? Yes. So this is where the E comes in. So we have A plus A inverse plus A inverse is equal to what? We want our E to be what? 0. So if you are finding A inverse, we leave A inverse, and send A across. We get negative A, right? So if you want A inverse, what do we do? Factorize A out, plus what? A is equal to negative A. A inverse is equal to negative A over
1 plus A.
1 plus A. When you do this, now come back. Come back and test. Test the inverse and see whether you get answers in the collection. Let's see. It says true. Or what it is? Show whether or not. So we don't know whether it's a group, right? So let's prove it. We are gotten the inverse. This is the inverse. The other one, it was just an operation, multiplication. So we know the inverse is 1 over that number, right? Here, it's a definition they have given us. So we are finished, and we know that divide A by 1 plus A. Is that not it? Yes. So pick a real number which is not negative 1. And let's see.
2 over.
Let's see.
2 over.
We are using what?
2.
We are using what?
2.
2 over
3.
1 plus 2. What do you get?
3. That's what I said.
So what will you get?
2 over 3.
2 over 3. The inverse of A.
A.
Our set is every real number except negative 1.
So one you cannot get negative 1.
Do you see why they say accept negative 1? Because of here. Do you see? If it's negative 1, it becomes 1 over 0. I get it. That's why they are wise already. They told us leave negative 1 away. So that any number, any real number, the set S is any real number except negative 1. So pick any real number, put inside and see whether it cannot be worked, it cannot be solved, you can't get a value. Do you see? So every real number you put inside, you get another real number. So automatically every real number except negative 1 has an inverse. Do you see? So I hope you are getting answers to that your question. So every real number has an inverse. So every element in S has an inverse. And 1. The operation. And the operation start.
The banner operation.
Show that
The banner operation.
the one operation is
Yes.
alright.
Define on a set T. After T.
Define
On a set
a set
T
T
equal to
equal to
curving brackets open P
P
comma Q
Q
comma R
R
comma S
S
closed
root
by the following table in
by
the following table in a group
following table
in a group
by the following table
in a group.
is what?
Get out the table.
It's a group. Right here is a group. I will show that. Star defined on a set T equal to Q, P, Q, R, S by the following table. So that means they have given us a table, right?
Yes.
How many rows? How many columns?
You just the set of the numbers. You can use that one until the 10. I mean,
Like this.
five columns. the set of the
This is one. E, Q, R, S, right?
Yes, the same thing.
So P, Q, right? P, Q, R, then what? S. So that means they filled the table for us.
No,
Right?
yes,
They filled it.
yes.
So fill it for us. Stop writing, please. Stop writing.
PQ. The
Stop
first one.
writing.
The first one.
Right.
P opening Q.
This guy, put your pen down. Yes, what?
So Q.
Huh?
Q.
Q. Take your time, my man.
S.
S,
P.
P,
R.
R,
S. The other one S.
S,
R.
R,
Q.
Q.
P.
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 What verb attend is
P. Yes.
P.
Q.
Q.
R.
R.
S.
S.
R.
R.
P.
P.
S.
S.
Q.
Q.
Yes.
That's all.
Yeah, that's one.
So what is my friend?
So what is a blue?
Put your pen down. It's to show that it's what?
A group.
So this is another type of question. So let's show the first one. Closure. Don't write please. Watch. So tell me. Put your pen down. Why is it called like that?
For that one there is it is.
You don't want to understand.
It's
We
blue.
haven't solved a question like this before.
What does
So
it
this
do?
is
Is that
So closure, let's see. What's the meaning of closure? It means all the values here must be where? It's a connection. Is it not so? Or to pick any two in the set, any two elements of the set, and you operate them, the result you get must be inside the set. You don't know what they did. They say P operation P, and they gave us Q. However, the rule of the binary operation, we don't care. They have done it, they have given us the answer. So P operation Q is this, P operation this is this, P operation this is that, they have given us the answer. Our lack is they have given us the answers already. So what do we do? We should just look at the answers they have gotten. Are all the values there in the given set? Yes. If they are all there, it means it's what? So is it closed? Yes. All the values they get by doing the operation, all of them are inside. So it's closed. Now two, actual activity.
you know how to breathe?
I will take you addition.
You always zoom this one so that you to be like hey, you see.
Any
To
three.
sit there like
B.
no, this one I'm not supposed
Operation Q.
to think they know.
Operation R, right? Yes. I'll give us P. Operation Q. Operation R. So do it for me. This is P. Then to the left side.
This one yeah,
P operation. Q operation R is what? On the table. Q operation R is what? Q. Are you watching? It's Q. We are coming to get P operation Q now. So P operation Q on the table. P operation Q is what? S. So we get S. That's left hand side. We are finally working left hand side. Can you all see? So now let's work right hand side. P operation Q. P operation Q is what? S. Operation R. So we're not going to find S operation what? R. S. Hey, my friend, put the pen down.
You also need to S.
What's your problem?
Second.
So S operation R. Where is S? S is here.
S.
R is here. S operation R. What do we get? S. Okay. So S operation R. We got what? S. I don't know what they say. Yeah. Any other three elements you pick, they will all do what? The same. So the operation under that is what? Associative. So let's go to the third.
Yes.
The third one is what? Identity.
Something.
Let's see whether the given set under the operation has what? Identity.
The guy spotted something.
Uh-huh.
What the video? It's not video well. So you maybe one moving to pause it and then do it then. You just everything now, just the soul.
Come and collect the guy.
You just pause we know you cannot do all this, so you are just taking it. So you before you to pause it and then so you just look at it and say no about the soul.
Hey, Kalu, let's finish.
So actually, if you're talking, he has not paused.
So what does it not say?
You didn't train him well.
It has. So P, operation E. Are you watching? Must give us what? P. Q, operation E must give us R operation what? R and E, sorry. Is that what they do for identity element?
Yes.
Want to find the identity element for the operation under the cell, right?
Yes.
So we have to check whether
Yes.
this S
Yeah.
operation E. So let's go P operation E. So what will we operate with P to get P? What is it then? Who can tell us? What will we operate? P operation E must give us P, right? Is that what they do? Eh? So what in the table? What did we operate with P to get P? P operation 1 gave us P. Are you watching? So here, in here, is R. Let's see again. Q operation 1 will give us Q. Q operation 1 will give us Q. What? Q operation 1. Q operation R will give us Q. Can you see it?
Yes.
So, R operation 1 will give us R. R here, operation 1. R gives us R. So, our next element S operation E must give us S, right? So we are asking ourselves, what will we operate with S to get S? From the same speed that it runs through all of them. So identity element is what? Is one value. Is that not it? Identity element has the identity element R. So it has identity. Once it has identity element, it has A. Stop talking, my friend. Now our rule says any of the element operation, the identity element must give us what? Must give what? Sorry, inverse. Any element with its inverse must give us what? What is our identity element? R. So what will we operate with P to get R? Is that what they mean? Can you all see? So it implies that. So let's go to the table. What will we operate with P to get R? Can you see? So P operation S is what? R. So our P inverse is what? S, eh? S. And let's go to Q. Q operation, Q inverse must give us E. So it implies Q operation, Q inverse must give us R. So what will Q inverse be? What will we operate with Q to get R on the table? Q operation, what gives us R? Q operation, Q gives us R. Can you see? Q operation, Q gives us R. So the inverse is Q. The inverse of Q is the same as what? Q. And let's go to R. Every element must have what? Its own inverse. Right? Yes. So R operation, R inverse must give us E. Implies R operation, R inverse must give us R. So R inverse on the table. What do we operate with R to get R? R operation R gives us R. Can you see? So the inverse of R is what? Is R. Can you all see? Every element has what? An inverse. And all of them are where? Inside the cell. Can you see? Are they not there? They're all there. S. We need to see them. S. So we are there with S. S operation what? S inverse will give us E. Implies S operation S inverse will give us R. So let's see. What do we operate with S to get R? Down here. S operation what gives us P? S operation what gives us R? P. Can you see? So S operation P gives you R. So what is the inverse of S? P. Thank you. So it extends here. These are our values. So every element has what? Its inverse. Every element has an inverse. So since every element has, so every element has an inverse. Every element has an inverse. So all the four properties or rules are what? Satisfied. So it implies that
set T is close.
T
It's a group.
and the operation is what? A group. Is that not it? That's the question. So T under the operation star is a group. Then for the top.
So the identity element.
Zn. If k is relatively prime to n, every non-zero k has an inverse in Zn. If k is relatively prime to n, every non-zero k, so k is a number. Every non-zero k has an inverse in Zn. If relatively prime. And the n here, k is relatively prime to n, relatively prime. And we are going to find the unit group of units. Denote the set of all such non-zero elements in Zn by Un. Denote the set of all such. Denote of all such non-zero. Then the group of units of Zn, you see, you could take U of 8, the unit group, modulo 8. So if you take U of 8, this is what we are talking about. So first, you need to know Zn. Are you watching? Zn. So Z of this number, which is Z8. Now, we already know how to write out elements of Z8. So we did that already. What do we get? 0, 3, 4, 5,
And brackets.
Very good. So these are elements of Z8. Now let's write U8. And to write elements of U8, they say elements that are relatively prime to the number n. Where is it? Relative prime to what? N. What is our n? Is so all these elements of Zn that are relatively prime to the number 8. Relatively prime means the only common factor between that number and the 8 should be 1. Are you there? There should be no common factor again, apart from 1 and 8. You see the meaning of relative prime? Yes. So you are coming to look at these numbers which are relatively prime to 8. 1, 3. Why don't we choose 2? You can tell that.
No.
There are other factors. Okay. So we have 1. This one is not there. This one is not there. 3 there. Yes. 3 is there. It's 4 there. No. Can you see? The only common factor between them should be 1. And it's any other factor that exists makes it not a relatively prime number. You see? So let's go. 4 is not there. Is 5 there? Yes. What of 6? No. 6 is not there. Can you see? What of 7? Yes. 7 is what? Also there. Easy. We have U8. So we can form a group. So U8. Unit group. U8. Which final operation? Let's use multiplication. Okay. Let's use multiplication. So, let's go to alternative 4. So this is our banner previous one. Dot and multiplication. So what are the elements of UV? 1, 3, 5, 7. We have 1, 3, 5, 7. So let's go. Let's see whether you remember what we did in the other examples and the model arithmetic. So 1 times 1. So if the answer is not in the model what? Model what? 1 times 1. 1 model 8. 1 times 3. 3 model 8. 1 times 5. 5 model 8. 7. That's easy. This way. So let's do the rest. 3 times 3, 9. 9 model 8. 3 times 5, 15. 50 model 8. 7. Yeah. 3 times 7, 21. Model 8. 8 times 5. 60. 5 times 3. 50 model 7. 5 times 5. 25. Is it 1? 25 model 8. 24. So minus 1. Easy. Israel, I got it. No. Yeah. 5 times 7 is what? 35. 8 times something will give you 32. So how many? 3 left. 7 times 3, 21. What did we get?
5.
You had 5, right?
Yes.
Okay. 7 times 5. What did we get? 35. 7 times 7. 49. 49. 8 times 1 will give you close to 49. 48. 8 times what? 8 times something give us 48, eh?
Yes.
Or 6. Yes. 8 times 6. Cross 48. So minus 1, right? Is it 1?
Yes.
Are you sure? See your secretary say. So 8. The other way, balance operation, when I just say group from here. You go and verify that. It should be. I can verify. You do what? You find what? What do you find? Closure. Is it close?
Yes.
Now,
Yes.
everything here is there. Is that anything? Or is that straight right? That's straight. Yeah, multiplication is straight, right? Then what is it?
Identity.
What's identity for multiplication? 1. Well, let's see what's identity here. Who can find the identity here? Identity element. Who can watch? Just watch and tell what's identity element here. Something operation, something should give us the same thing. 1. 1 times 1 is 1.
Yeah.
3. 3 times 1, 3. 5 times 1. So the identity is what? 1. Can you see? Can you all see? The identity here is 1. Are you confused? No. The identity is 1. So you have to have identity. Then every element has an inverse. All the inverse of 1, who can tell us? 1 inverse, here is 1. Something operation, the inverse will give you what? Identity. So how will you operate with 1 to get 1? 1 with 1 is 1. How will you operate with 3 to get 1? 3 with 3. So we say the inverse of 1 is what? 1. Inverse of 3. What will you operate with 3 to get 1? 3 with 3 is 1. Can you see? Yes. What? 3, And the inverse of what? They get 5. 5 inverse. What will you operate with 5 to get 1? 1 with 5 give us 1. Right, so the inverse of 5 is 1.
7.
What the inverse of 7?
7.
The inverse of 7. All of them with 7 to get 1.
7.
Can you see? The inverse of this. So every element has an inverse. Trend on the structure. Let's look at how a group came about. Let's look at how a group came about. 7 group. Monoid. Before the monoid now gave birth to what we call the properties of a group. We listed the properties of a group as closure, is that not it? As what? Utility. Identity. Inverse. Okay, so every element has an inverse. And the final operation for that given set has an identity element. So you see, now these are the 4 attributes or properties or features of anything we call what? A group. Now watch. The group point is in an empty set. That is true. The first one. Are you watching? The group point is in an empty set. That is true. That's what we call what? A group point. Now, a semi-group is a group point. Are you watching? That is what? Are you watching? The next one is semi-group. Semi-group is a group point. That is associative. So before you can be semi-group, you must first be what? A group point. That means you must what? First be what? Group. Are you seeing the group? So the third one is a monoid. Now a monoid must have what? Identity element. So a monoid is also a semi-group in which the binary operation has what? An identity element. You see, that's the meaning. So this one has identity element. Then go to the last one, which is what? Inverse. So you see, so this one also now depends on a monoid. So a group is not a monoid with what? In which every element has what? An inverse. And you see how the structure is. So a group is built from here to any monoid with what? In which every element has an inverse. You see why we have these properties as properties of a group. So this is the reason why we have these 4 properties as properties of a group. So a group is a monoid in which every element has what? An inverse. But you know a monoid has an identity element, so automatically a group must have identity, the binary operation. A monoid also is this, so automatically it must be closed. A group, semi-group T is this, automatically it must be closed. Do you see? That's the meaning. Any question? Number of elements is called a finite group. It's called a finite group. denote order of the group in so we denote the order of a group by the two straight lines, capital or order of A. Order of A. Number of elements of that. If the set, if the group is infinite, then it has an infinite one. Then it has an infinite one. Then it has an infinite one. If I give you what's the order?
Shit.
It's what? Hey, why are you here? You have to read what you are writing. Don't just copy, you don't read. So we said what? The number of elements of such a group, of a finite group. A group which has a known number of elements. There are 10, there are 20, there are 50. Is that what the meaning? Yes. So the order talks about the number of elements of a given set, given group. Are you okay? So now you have been given this group A. These are the elements. What's the order? It's what? So the order